Good day everyone, and welcome to my class. I am Jeralyn Penetrante. I will be the one who will teach you and guide you in one of the topics in Abstract Algebra. So have a pen and paper beside you for us to have fun in learning today. But before we start, let's have a short activity entitled Finding R, wherein I know you already mastered in your elementary mathematics, which is finding the remainder and division of integers. So now, let's begin. Let's find the remainder of the following starting on number 1, which is 19 over 4. Number 2 is 100 over 9. Number 3 is 234 over 23. Number 4 is 569 over 45. And number 5 is 101 over 69. You can try answering these questions while pausing the video before I present the answer and see if you are correct. Let us check if your answers are correct. So for number 1 is 3. For number 2 is 1. For number 3 is 4. For number 4 is 29. And lastly, the answer is 32. What if I ask you to find the remainder of 2 raised to 2022 when we divide it by 5? Will it be easy for you to answer this even if you have a scientific calculator? It's okay. I know what you are thinking. It will give you a hard time in finding the remainder since we have a big exponent in our given. So don't fret, because our topic for today will guide us in solving problems like that, which is Modulo Congruence. This lesson has 3 objectives. At the end of the lesson, you will be able to recognize the modulo congruence. The second one is to identify congruent numbers under a particular modulo. And the last one is to find the remainder by using the modulo congruence. The modulo congruence says that if m is a positive integer and m divides a minus b, then we say that a is congruent to b modulo m, and in symbol, note that these two statements are equivalent and may be used interchangeably, where a is the dividend, b is the remainder, and the last one, which is m, our divisor. To further understand this concept, here are some examples. Example number 1 is 31 is congruent to 7 modulo 8, since 31 minus 7 is a multiple of 8. Number 2, which is 40 is congruent to 4 modulo 9, since 40 minus 4 is a multiple of 9. Number 3, which is negative 68 is congruent to 1 modulo 3, since negative 68 minus 1 is a multiple of 3. And the last one is number 4, which is negative 87 is congruent to negative 2 modulo 5, because negative 87 minus negative 2 is a multiple of 5. Now, let's have a true or false. I will give you 5 seconds to answer each item. False, because 12 minus 3 is not a multiple of 6. False, because negative 13 minus negative 3 is not a multiple of 4. True, because negative 22 minus 2 is a multiple of 6. Papunta pa lang tayo sa exciting part. But before we proceed to a more complex part, we must know that the remainder is called least residue, where the value of the remainder is less than the value of the denominator. This time, we are now going to answer the question we left earlier by using the modulo congruence, which is the remainder of 2 raised to 2022 when we divide it by 5. So now, let's have a solution. By definition of modulo, and assuming that the remainder is r, we have 2 raised to 2022 is congruent to r modulo 5. Recall that 2 squared is equal to 4, and we are going to substitute it to our r. It will be 2 raised to 2022 is congruent to 2 squared modulo 5. Since 2 squared is not yet divisible by 5, we are going to transfer 2 squared on the left side, and the new value on its place will be negative 1, as 2 squared minus negative 1 is already divisible by 5. Next step is to exponentiate both sides by 1011 to go back to 2022. We can get this by dividing 2022 by 2. And now, let's simplify negative 1 raised to 1011. It will be negative 1 as suggested by its odd exponent. Hence, the least residue must be from 0 to 4. So we are now going to solve for it in this way. R minus negative 1 is equal to 5. Through solving for r, we will discover that the remainder of 2 raised to 2022 when we divide it by 5 is 4. That is within the residue from 0 to 4. The next question, we have 5 raised to 1999 to be divided by 13. Let's try solving the remainder by having a solution. By definition of modulo and assuming that the remainder is r, we have 5 raised to 1999 is congruent to r modulo 13. Recall that 5 squared is equal to 25, which is the nearest to 26 that is divisible by 13. Hence, by substituting 5 squared to our r, it will be 5 raised to 1999 is congruent to 5 squared modulo 13. However, 5 squared is not yet divisible by 13, so we will try to transfer it to the left side and to be subtracted by negative 1 to make it divisible by 13. Exponentiate now both sides to make it 2022. It will be 5 squared raised to 999 is congruent to negative 1 raised to 999 modulo 13. We will get 999 by dividing 1999 by 2. Observe that negative 1 raised to 999 is still negative 1, as predicted by its odd exponent. Multiply both sides by 5 to make it 1999. We have now 5 raised to 1999 is congruent to negative 5 modulo 13. It is now complete. And by transferring negative 5 on the left side, we have negative 5 is congruent to r modulo 13. But negative 5 is not yet the least residue from 0 to 12. We will solve for r by getting the difference of r and the dividend. In doing that, we will achieve the value of r, which is positive 8. That is within the residue from 0 to 12. Let's now try solving for the remainder of our last example, which is 3 raised to 2023 when we divide it by 20. We must have a solution, of course. By definition, of modulo and assuming that the remainder is r. We have 3 raised to 2023 is congruent to r modulo 20. Recall that 3 raised to the 4th power is equal to 81, the number that is the nearest to 80, which is divisible by 20. Hence, by substituting 3 to the 4th power to r, it will be like this. But 3 raised to the 4th power is not yet divisible by 20, so it must be subtracted by 1 as we transferred it to the left side, which is 3 raised to the 4th power is congruent to 1 modulo 20. And by exponentiating both sides, we have 3 raised to the 4th power raised to 505 is congruent to 1 raised to 505 modulo 20. We will obtain 505 by dividing 2023 by 4. So by simplifying it, we will be having 3 raised to 2020 is congruent to 1 modulo 20. But 2020 is not yet 2023. We will multiply both sides by 3 cubed to make it complete 2023. However, 3 cubed is not yet a least residue, but when we subtract by 7, we will be assured that r is 7, which is within the least residue from 0 to 19. Now, you can solve these try examples while pausing the video before I reveal the answers in 5 seconds. And there you have it. We have discussed the modulo congruence, specifically on how to determine congruent numbers under a particular modulo, and how to find the remainder with big exponents. Let's have a recap. The modulo congruence says that if m is a positive integer and m divides a minus b, then we say that a is congruent to b modulo m, and in symbol, note that these two statements are equivalent and may be used interchangeably. The remainder is called least residue, where the value of the remainder is less than the value of the denominator. How are you in our today's lesson? I know you did an amazing job. I hope that you learned a lot today. I want you to know that it's okay to commit mistakes, but the only thing that it's not okay is when we don't learn from them. See you again for the next video. Bye!